Narrator: Miss Elfie Hannah Baranian, and Mr. Onyx Baranian. Daughter and son of Mr. Rufino Rufio Baranian.
Ryanyx Construction and General Services Corporation. 2.2 kilowatts to 12 kilowatts. Gear-driven, self-powered permanent magnet generator, continuous green power supply system, aka Ever Motor System, Green Energy. September 11, 2020, innovation designed and developed by Rufino Rafi L. Barinian, Chairman and CEO of Ryanyx Construction and General Services Corporation. Final draft number 7 dated September 11, 2020. Title: Gear-driven, self-powered permanent magnet generator, continuous green power supply system. Field of invention: a mechanical electrical power generation system that can continuously generate its own green energy power and supply continuous surplus power. Inventor: Rufino Rafi L. Barinian from Cebu, Philippines. Abstract: the gear-driven, self-powered permanent magnet generator system requires an understanding of Newton's third law of motion, low-high voltage electrical controls, instrumentation controls such as open and closed loop, cascade, telemetry, supervisory, and data acquisition. Combined with principles of mechanical and civil engineering utilizing an asynchronous drive motor, 2 gearboxes with customization of materials and hardness of the output shaft and output gear teeth of second gearbox, which sustains the rated speed of permanent magnet generator operating at its rated torque. The drive motor starts initially from green power sources such as wind, solar, biodiesel generator, local utility provider, or a battery-powered inverter powering other inverters for 5 to 10 minutes until drive motor, gearboxes, and generator are synchronized. The second gearbox produces a reduced speed output, higher torque, and transform to the high speed needed to drive the generator, which returns the power back to run the drive motor, with surplus power available for other use or sold to the local utility.
Background: it should be understood at the outset that, although exemplary embodiments are illustrated in the figures and described below, the principles of the present disclosure may be implemented using any number of techniques, whether currently known or not. The present disclosure should in no way be limited to the exemplary implementations and techniques illustrated in the drawings and described below. Although specific advantages have been enumerated herein, various embodiment may include some, none, or all of the enumerated advantages. There are additional features of the instant invention that will be described hereinafter, and which will form the subject matter of the claims appended hereto. In this respect, before explaining at least one embodiment of the instant invention in detail, it is to be understood that the instant invention is not limited in its application to the details of construction and to the arrangements of the components set forth in the following description or illustrated in the drawings. The instant invention is capable of other embodiments and of being practiced and carried out in various ways. Also, it is to be understood that the phraseology and terminology employed herein are for the purpose of description and should not be regarded as limiting. These, together with other objects of the instant invention, along with the various features of novelty, which characterize the instant invention, are pointed out with particularity in the claims annexed to and forming a part of this disclosure. For a better understanding of the instant invention, its operating advantages and the specific objects attained by its uses, reference should be made to the accompanying drawings and descriptive matter in which there are illustrated preferred embodiments of the instant invention. Other technical advantages may become readily apparent to one of ordinary skill in the art after review of the following description figures and drawings. Typically, when a drive motor is connected to drive a single gearbox or an array of multiple gearboxes which are connected to a permanent magnet generator or a pump or some other equipment which requires to be driven by the drive motor, the operating performance characteristics of the drive motor and gearboxes are determined by the manufacturer, who is following Newton's third law of motion, which is for every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the forces on the first object equals the size of the force on the second object. Expressed as a formula, the aforementioned Newton's law is as follows. Torque Nm equals constant times power kW divided by speed, rpm. Normally, a motor takes power in the form of voltage and current which is taken from a source that is operating 24 hours per day, 7 days per week, 365 days per year. The source is either generated from a company power station or purchased from an external power source through the local utility provider. This power is converted over time into mechanical energy, for example in the form of rotation of a shaft attached to the drive motor to operate another device, such as a gearbox, pump, or permanent magnet generator. Generally, the manufacturer of a drive motor also manufactures gearboxes, both requiring speed to be expressed as RPM and torque to be expressed as Newton meters, both calculated according to the aforementioned Newton's law formula. A person skilled in the art will claim that it is not possible to get more from a system than is put into the system. In other words, for units of energy used to power into a system, the system can only return same number of units of energy and most likely less units, due to inherent system inefficiency. This instant invention at hand will defy Newton's law, as it not only produces more power from the system than is used to drive the system but also provides enough power to return to the drive the system, as well as have surplus power for supply outside the system for other use or sell to the local utility provider. Prior art investigation number 1, United States Patent Application number US 2011-01810488A1 dated July 28, 2011, titled Gear-Driven Energy Transfer System, issued to Mr. Christopher Scotty, teaches of an energy transfer system comprising a first power conversion system, wherein the first conversion system further comprises an electric drive motor, a gearbox, wherein the gearbox is in communication with the electric drive motor, a transmission, wherein the transmission is in communication with the gearbox, a first generator, wherein the first generator is in communication with the transmission, a second power conversion system, wherein the second conversion system is disposed to be in electric communication with the first power conversion system and further comprises a second electric drive motor, a second gearbox, wherein the second gearbox is in communication with the second electric drive motor, a second transmission, wherein the second transmission is coupled to the second gearbox, a second generator, wherein the second generator is coupled to the second transmission, and a plurality of energy sources, wherein the plurality of power sources is disposed to operate the electric drive motor of the first power conversion system. It could be argued that Mr. Scotty's gear-driven energy transfer system is not novel and has no commercial value, as it is stated in the patent that the plurality of power sources is disposed to operate the electric drive motors of the first power conversion system. If the power generated only drives the first electric drive motor, then there is no commercial value or use of the gear-driven energy transfer system, because it only produces electricity to power itself. Mr. Scotty claims that his gear-driven energy transfer system is an invention. As a contrary opinion, Mr. Scotty has been granted a patent for a design which is not an invention. Expressed another way, there is no known use for the design because there is no surplus power generated. A person skilled in the art will note that Mr. Scotty's gear-driven energy transfer system follows Newton's law formula, being torque Nm equals constant times power, kW, divided speed, rpm, which produces only sufficient power to operate the system. There is no additional power produced that can be used outside the gear-driven energy transfer system, whereas this instant invention at hand does produce power in addition to the power required to operate this gear-driven self-powered permanent magnet generator continuous green power supply system. Mr. Scott's design of a gear-driven energy transfer system relies upon a connecting belt drive to transfer speed and torque from a transmission to a gearbox. His design includes 2 drive motors, 2 gearboxes, 2 generators, 2 transmissions, collectively totaling 8 separate mechanical pieces of equipment. By comparison, this instant invention at hand, gear-driven, self-powered permanent magnet generator, continuous green power supply system, comprises 1 drive motor, 2 gearboxes and 1 permanent magnet generator, collectively totaling 4 separate mechanical pieces of equipment. Prior art investigation number 2 Philippine application number PH1 2013-000-284 titled A New Mechanical Assembly with an Efficient and Multi-Purpose Gearbox System for Fuelless Motor and Fuelless Generator filed on September 24, 2013 by Mr. Henaro Francis Tabag, teaches of the construction of a new mechanical arrangement, with an efficient multi-purpose gearbox system, assembly adaptably suited to induction motors and generator motors that may produce free electricity. The base frame is designed with a stainless 1 1/2 inch square tube, having a length of the base frame at 40 inches, width of 13 inches and height 4 inches. Motors can be fixed or adjusted horizontally and vertically to mesh with the gearbox gears with proper alignment. The base frame can also be used for different motor sizes ranging from 1 to 10 horsepower. Gearbox can be fixed or adjusted vertically. A person skilled in the art will observe that Mr. Tabag is incorrectly claiming that his mechanical arrangement is an invention. It can only be claimed to be a design of a new setup of a mechanism, as it follows Newton's law formula torque, Nm, equals constant times power, kW, divided by speed, rpm, which produces only sufficient power to operate the system and no surplus power is produced. Mr. Tabag mentions on page 3 and 4 that, if the input gear is 1740 revolutions per minute, the output gear should have 150 top 200 revolutions per minute for the generator motor to produce sufficient power. A person skilled in the art would know that a generator and a motor have 2 different functions. The generator will produce electricity when the shaft will be turned, and the motor will turn when the electricity will be powered and produces speed and torque. However, no generator with a speed between 150 to 200 revolutions per minute can produce sufficient power. The lowest speed that a generator can produce power is 600 revolutions per minute, and the performance efficiency is not greater. Mr. Tabag mentions fuelless motor and fuelless generator, but there is no mention about the source of energy and the amount energy required to operate the system. There is mention of production of greater power, but the energy required by the system and produced by the system are not quantified. Summary. The prototype embodiment of the gear-driven, self-powered permanent magnet generator system comprises a bespoke asynchronous drive motor of only 2.2 kilowatts capacity, 1750 revolutions per minute, driving and connected by coupling to a bespoke high-speed to low-speed gearbox number 1 connected by coupling to a bespoke low-speed to high-speed gearbox number 2 connected by coupling to a bespoke 12 kilowatts capacity 1200 revolutions per minute permanent magnet generator. Attached through 2 gearboxes to the 2.2 kilowatts drive motor, which starts from a 12V DC lead-acid or lithium battery, 24V lead-acid or lithium battery for 5.5 kilowatts and above drive motors, powering a variable frequency drive inverter number 1 which provides 220 VEC to a connected variable frequency drive inverter number 2 which provides 380 VEC to the 2.2 kilowatts drive motor, which starts for 5 to 10 minutes turning the 12 kilowatts gear-driven self-powered permanent magnet generator, and, after synchronization with the drive motor and the 2 gearboxes, will come online to feed, after deduction of 7% or 0.84 kilowatts efficiency loss, 0.1% or 0.01116 kilowatts for system instrumentation and controls, 0.4 kilowatts returned to the variable drive frequency inverter number 1. The balance of 8.949 kilowatts or 74.6% of generated power output is dispatched to the local utility provider or to the utility distributor or to the system owner for powering other equipment. As to balancing the system, if the set point of how much power percent is required to feed to the local utility provider, the variable frequency drive inverter will maintain the speed, RPM, to achieve the exact demand of the set point and output of the gear-driven self-powered, permanent magnet generator. The conceptualization of the gear-driven self-powered permanent magnet generator system is unique and novel as it was created by not following Newton's law formula of torque, Nm, equals constant times power, Kw, divided by speed, RPM, for the output gear of gearbox number 2. Newton's law formula is only followed for the torques and speeds of the asynchronous drive motor, gearbox number 1, input gear of gearbox number 2 and the permanent magnet generator. Proof of concept of the gear-driven self-powered permanent magnet generator system was established by operating the system, non-stop for 120 hours, a prototype embodiment of the instant invention being a 2.2 kilowatts asynchronous drive motor connected by coupling to a high-speed to low-speed gearbox number 1 which is connected by coupling to a low-speed to high-speed gearbox number 2 which is connected by coupling and turning a 12 kilowatts permanent magnet generator from which 0.4 kilowatts is returned to the drive motor, 0.1% used to power system control instruments and the balance was dispatched for local power use. The prototype embodiment comprised an asynchronous drive motor with rated power of 2.2 kilowatts at 1,750 revolutions per minute rated speed, reduced to 1,500 revolutions per minute, and torque of 12.0 Newton meters, increased to 14.0 Newton meters, coupled to drive gearbox number 1, high speed to low speed, with a rated input speed per torque of 1,500 revolutions per minute per 14.0 Newton meters and a rated output speed per torque of 188 revolutions per minute per 112.0 Newton meters, coupled to gearbox number 2, low speed to high speed, with a rated input speed per torque is 188 revolutions per minute per 112.0 Newton meters and, except for the output gear of gearbox number 2, is still following Newton's law formula, with a rated output speed of 1,500 revolutions per minute. The material hardness of the output gears and the adjustment of the size of the output shaft diameter are customized to resist the rated speed and torque of the gear-driven self-powered permanent magnet generator at 1,200 revolutions per minute with rated torque at 96.9 Newton meters, respectively. Specifically, the diameter and width of the output gear of gearbox number 2 must be equal to or greater than input gear of gearbox number 2 and the output shaft diameter of gearbox number 2 must be identical to the input shaft of the permanent magnet generator. The drive motor speed is rated at 1,750 revolutions per minute but is controlled by the proportional integral controller that signals the variable frequency drive inverter to reduce, either manually or automatically. The drive motor speed is controlled to 1,200 revolutions per minute to equal to the 1,200 revolutions per minute speed of the gear-driven self-powered permanent magnet generator. In order not to damage either or both gearboxes installed in the system, the set point of the proportional integral controller for the drive motor is set at 80% to reduce the input speed of the gearbox number 1 from 1500 rpm, 14.0 Newton meters torque, to 1,200 revolutions per minute, 17.55 Newton meters torque, with an output speed reduced from 188 revolutions per minute, 112.0 Newton meters torque, to 150.4 revolutions per minute, 140.1 Newton meters torque. Gearbox number 2 will operate at a reduced input speed of 150.4 revolutions per minute per 140.1 Newton meters torque, down from 188 revolutions per minute per up from 112.0 Newton meters torque, and reduced output speed of 1,200 revolutions per minute, down from 1500 rpm. However, as the gearbox number 2 output shaft is the same diameter as the permanent magnet generator shaft diameter, which requires a larger than normal diameter of the output gear, with both shaft and gear manufactured from high-grade materials 20 cr Nitumo gear, and 42 cr/mo shaft, respectively, and hardness HRC 5862 gear and HB 580 shaft, respectively. The torque of gearbox number 2 output shaft will be minimum 112.0 Nm, same as input torque, thus being sufficient torque to drive the gear-driven self-powered permanent magnet generator, which has a rated torque of 96.9 Nm. Once the 80% set point is reached from the speed of the drive motor, the feedback signal from the speed of the permanent magnet generator at 1200 revolutions per minute will give a signal to activate the switchgear for ready load shedding and load sharing, and the 12 kW gear-driven self-powered permanent magnet generator will by itself return 0.4 kW power back to the 12V DC battery charger, which will power the variable frequency drive inverter number 1, 12V DC to 220 VAC, which in turn power the variable frequency drive inverter number 2, 220 VAC to 380 VAC, which will power the 2.2 kW drive motor, as well as share 0.1% for powering system instrumentation, and the excess power will feed to the user's other equipment or directly to the utility distributor, with the system running continuously 24/7 365 days. A person skilled in the art will recognize that multiple embodiments of the gear-driven, self-powered, permanent magnet generator system, such as but not limited to drive motor or permanent magnet generator, combinations of, but not limited to 45 kW per 200 kW, 45 kW per 280 kW, 250 kW per 600 kW, 250 kW per 1000 kW, 500 kW per 1250 kW, 650 kW per 3000 kW, 1120 kW per 5000 kW, 1120 kW per 6500 kW, and 1200 kW per 6500 kW, can be linked in an array, in parallel, to operate as a standalone power station that can be connected to substations for distribution of power, to factories, or available for public use. As such a multiple array of connected systems are self-generating power, there will negligible exposure to brownouts or blackouts, which particularly occur frequently here in the Philippines. This gear-driven, self-powered permanent magnet generator, continuous green power supply system, is an instant invention because it is not following and is not guided by Newton's law formula in the design and operation of gearbox number 2 used to drive gear-driven, self-powered permanent magnet generator. It is not only unique, but also peculiar because the small input of the drive motor drives the bigger output of the gear-driven self-powered, permanent magnet generator. Apart from the initial start, the system is self-powered, operating 24/7, 365 days without end users of the power produced suffering brownouts or blackouts, which normally occurs in the Philippines, when supplied by the local utility provider. An embodiment of the instant invention will enable a gear-driven, self-powered permanent magnet generator, continuous green power supply system to be operated without returning power to the drive motor. Permanent power to the drive motor will come from wind and/or solar, if available, with backup from the local utility provider. Except for 7% efficiency loss of the 12 kW permanent magnet generator plus about 0.011 kW, 0.1%, for power to the system instrumentation, a total of 11.15 kW or 92.9% of the 12 kW permanent magnet generator capacity would be available for other use elsewhere in the factory, plant, or to sell to the local utility provider. It will require 2.2 kW to be purchased from the local utility provider to power the drive motor. A further embodiment of the instant invention will enable the gear-driven self-powered, permanent magnet generator, continuous green power supply system, to be operated with combinations of different types of drive motors and generators. It will be possible to use asynchronous drive motors, driving induction generators, synchronous drive motors, driving induction generators, and synchronous drive motors, driving permanent magnet synchronous generators. All embodiments will generate surplus power for other use or sold to the local utility provider, after deducting power to be returned to the drive motor, and also for system control purposes. Description of figures. While the specification concludes, with claims particularly pointing out and distinctly claiming the present instant invention, it is believed that the present instant invention will be better understood from the following description in conjunction with the accompanying drawing figures, in which like reference numerals identify like elements, and wherein. Figure 1. Picture of actual prototype showing the drive motor coupled to gearbox number 1, coupled to gearbox number 2, coupled to the permanent magnet generator, with all power supply connected to the control panel. Also shows speed and torque parameters of the connected equipment as well as frequency, voltage and power. Figure 2. Single line diagram of the prototype showing the interconnection of the main equipment. Figure 3. Control panel and the internal circuit. Figure 4. External power and internal power supply of the variable frequency drive to power up the drive motor. Figure 5. Schematic drawing with external power supply to the local electricity provider. Figure 6. Schematic drawing switching power supply from the external source to self-power from generator. Figure 7. Video link showing the operation of the prototype of the instant invention. Detailed description. This instant invention was designed and innovated based on an understanding of Newton's third law of motion, low and high voltage electrical controls, instrumentation controls such as open-loop control, closed-loop control, cascaded control, telemetry control and SCADA, supervisory control and data acquisition, combined with principles of mechanical and civil engineering utilizing the asynchronous drive motor, 2 gearboxes 3 and 4 with customization of the materials and hardness of the output shaft and gear teeth of the output gear of gearbox number 2-4, which provides the force or starting torque expressed as Newton meters, Nm, and the speed expressed as revolutions per minute, RPM, of a permanent magnet generator 5 to operate at its rated torque. Civil engineering is used to determine the exact location for the sound level, soil bearing test for the foundation and slab as well as minimize the vibration of the moving equipment. Figure 1 illustrates the four mechanical components that are used in the gear-driven self-powered permanent magnet generator continuous green power supply system. Start power 1 required is 5 kVA from sources such as wind, solar, biodiesel generator, battery bank inverter or grid. The system comprises a 2.2 kW asynchronous drive motor 380 VAC, 0 to 60 Hz with rated speed of 1750 revolutions per minute, torque of 14 Nm as shown in Figure 1 coupled with the gearbox number 13 with input speed of 1500 revolutions per minute, input torque of 14 Nm and output speed of 188 revolutions per minute, output torque of 112 Nm. The output shaft of gearbox number 13 with diameter of 30 mm is connected by coupling 6 to the input shaft of gearbox number 24 with diameter of 35 mm. Gearbox number 24 input speed is 188 revolutions per minute with input torque of 112 Nm and output speed is 1500 revolutions per minute with a torque that supplants the Newton's law torque with higher grade and hardness of gear and shaft materials. The output shaft of gearbox number 24 with diameter of 42 mm is connected by coupling 7 to the same size 42 mm shaft of the 12 kW synchronous permanent magnet generator 5 with rated speed of 1200 revolutions per minute with 380-220 VAC 60 Hz output. While this instant invention is based on an embodiment prototype of a 2.2 kW drive motor 2 and 12 kW permanent magnet generator 5, the instant invention has various embodiments of size, meaning that it can be upscaled to allow for installation of drive motor 2 per permanent magnet generator 5 combinations such as but not limited 45 kW per 200 kW, 45 kW per 280 kW, 250 kW per 600 kW, 250 kW per 1000 kW, 500 kW per 1250 kW, 650 kW per 3000 kW, 1120 kW per 5000 kW, 1120 kW per 6500 kW and 1250 kW per 6500 kW. The aforementioned different size combinations could be linked together to operate in parallel. Embodiments of other drive motor 2 per permanent magnet generator 5 combinations will be possible but subject to equipment availability, optimum operating parameters, and cost. Figure 2 illustrates the single-line diagram of the prototype of the gear-driven self-powered permanent magnet generator continuous green power supply system. The external power supply one is initially coming from wind, solar, biodiesel generator, battery bank connected to variable frequency drive, VFD, inverter number 1, 10 or grid. The input power supply 8 with 3-pole, 30-ampere circuit breaker and 2-pole circuit breaker connected to magnetic contactor KM19 connected to the variable frequency drive, VFD, inverter number 110 from the variable frequency drive, VFD, inverter number 110 connected to the drive motor 2. The shaft of the drive motor 2 connected to the input shaft of gearbox number 13, and the output shaft of gearbox number 13 is connected by coupling 6 to the input shaft of gearbox number 2. 4. The output shaft of gearbox number 24 is connected by coupling 7 to the shaft of the permanent magnet generator 5, to drive the 12 kW permanent magnet generator 5. The magnetic pickup speed sensor 11 is connected to the outboard shaft of the permanent magnet generator 5 to monitor and indicate the speed of the permanent magnet generator 5 in the control room. When the system operates, the permanent magnet generator 5 output voltage indicator light 12 is illuminated, the current indicator light 13 is illuminated, and the test load panel light 14 is illuminated. The magnetic contactor KM215 will energize to take over the power from the external source 1, upon which occurrence the system is powered by itself. At this stage, the load to energize magnetic contactor KM316 with 50% load, 75% load for magnetic contactor KM417 and 100% load of magnetic contactor KM518. The 2.2 kW drive motor 2 starts from a 12V DC lead-acid or lithium battery. 24V DC lead-acid or lithium battery for 5.5 kW and above drive motors 2, powering a variable frequency drive, VFD, inverter number 110 which provides 220 VAC to a second variable frequency drive, VFD, inverter number 219 which provides 220 VAC to 380 VAC to power the 2.2 kW drive motor 2. Figure 3 illustrates the control panel indications and the internal circuit of the prototype of the gear-driven self-powered permanent magnet generator continuous green power supply system. The front view outside cabinet. Control panel 21 shows the indicators monitoring of frequency, voltages, amperes, indicating light, start and stop push button. The front view of the internal cabinet control panel 22 shows the internal installation of the circuit breakers, magnetic contactors 9, 15, 16, 17, 18, 25, terminal block, wiring ducting and control wirings and power wirings termination. For 200 kW and above drive motors to a third variable frequency drive, VFD, inverter number 320 will provide 380 VAC to 380 VAC to power the larger drive motors 2. The temporary battery startup power for variable frequency drive, VFD, inverter number 110 will automatically disengage when the drive motor 2, gearboxes 3 and 4 and permanent magnet generator 5 system is stabilized and reaches the required 1200 revolutions per minute speed of the permanent magnet generator 5 and will return 0.4 kW to the battery charger of the 12 DAC per 220 VAC variable frequency drive, VFD, inverter number 110 and 0.1%, 0.01116 kilowatts, for operating electronic and electrical controls of the system. It is expected to take 5 to 10 minutes to synchronize between the temporary startup power supply and the installed gear-driven self-powered permanent magnet generator 5 and produces the correct frequency, 60 Hz, and voltage output, 380 VAC, from the said gear-driven self-powered permanent magnet generator 5. The drive motor 2 has a rated speed at 1750 revolutions per minute but with the installation of a variable frequency drive, VFD, inverter number 110, to control the output speed of the drive motor 2, as well as the high speeds of the 2 intermediate gearboxes 3 and 4, high speed to low speed per low speed to high speed, are reduced to 1200 revolutions per minute to match the 1200 revolutions per minute speed of the gear-driven self-powered permanent magnet generator 5, which forms the power generation part of the system. Gearbox number 1, 3. Has a rated input torque of 14.0 Nm, which is increased to 17.55 Nm, due to the rated input speed of 1500 revolutions per minute reduced to the lower input speed of 1200 revolutions per minute from the drive motor 2, and is necessary to drive the input gear at 1200 revolutions per minute, reduced from 1500 rpm. Resulting in the output torque of 112.0 Nm, increased to 140.06 Nm, necessary to achieve a reduction in the rated output speed from 188 revolutions per minute to 150.4 revolutions per minute, thus operating at a high speed to low speed configuration. Gearbox number 1, 3. Is connected to gearbox number 2 4, inducing an input torque of 17.55 Nm, increased from the rated 14.0 Nm input torque, driving the input gear speed at 150.4 revolutions per minute, reduced from the rated input speed of 188 revolutions per minute, which is connected to the gearbox number 1 3 output gear with an output torque of 140.06 Nm, increased from the rated output torque of 112.0 Nm, at 1200 revolutions per minute, reduced from the rated 1500 revolutions per minute, which is the speed to match the 1200 revolutions per minute rated speed of the gear-driven self-powered permanent magnet generator 5, thus operating at a low speed to high speed configuration. Gearbox number 2, 4, with its bespoke designed torque, Nm, speed, RPM, ratios, shaft sizes and output gear, increased diameter and width, as well as shaft material and hardness, produces an increased output shaft torque. And required high speed of 1200 revolutions per minute needed to drive the attached gear-driven self-powered permanent magnet generator 5, which in turn generates the required electrical power output of 0.4 kW to run the variable frequency drive, VFD, inverter number 110 and 0.1%, 0.01116 kilowatts, for operating electronic and electrical controls of the system, with the surplus power of 8.949 kilowatts being dispatched to the local utility provider or for other use in the plant or factory. The control instrumentation, switchgear and magnetic contactors, step-down transformer and step-up transformer form part of the gear-driven self-powered permanent magnet generator 5 continuous green power supply system and are designed to provide a control loop for the distribution of the net-generated electrical power to the local utility provider and other end users while reserving electricity to return back to the drive motor 2 in order to maintain and perform a continuous operating cycle. Asynchronous drive motor. For the prototype, a smaller drive motor 2 is utilized with a capacity of 2.2 kilowatts, 3-phase, 1750 revolutions per minute, 380 VAC, 60 Hz. The selection of the drive motor 2 is based on adopting a centralized control system that can control the frequency, voltage and RPM with the added advantage of driving the combination of two gearboxes 3 and 4 linked by couplings 6 and 7 to the gear-driven self-powered permanent magnet generator 5. The initial power source is the 12V DC battery-operated variable frequency drive, VFD, inverter number 1, 10, but it is variable frequency drive, VFD, inverter number 219 that will power and control the drive motor 2, with two input signals, 4 to 20 mA, RPM and load respectively, with a cascade control instrument with one output signal, 4 to 20 mA, that will proportionally control the speed of the drive motor 2 and to synchronize the speed of gear-driven self-powered permanent magnet generator 5. Under Newton's law formula, beam torque, Nm, equals constant times power, kW, divided speed, RPM, the force of the 2.2 kilowatts drive motor is equal to a torque of 17.55 Nm with speed at 1200 revolutions per minute, rated at 12.0 Nm, torque at 1750 revolutions per minute. and 14.0 Newton-meters torque at 1,500 revolutions per minute. This force will be controlled proportionally in terms of speed, frequency, load capacity and rated torques for the starting of the combined equipment and electronic controls that make up the system. The rated speed of the drive motor 2 is 1,750 revolutions per minute and can be controlled at speeds ranging from 1 revolution per minute to 1,750 revolutions per minute, or a set point ranging from 0% to 100%, which depends on the actual status of the operations that the control room operator decides to fix the set point based on the demand of the power control system. The set point is fixed so that the output speed of the drive motor 2 is equal to the speed of the gear-driven self-powered permanent magnet generator 5, which for the prototype is 1,200 revolutions per minute, thus the set point of the drive motor 2 will be fixed as required within a range between 1170 revolutions per minute and 1230 revolutions per minute, which frees up 580 revolutions per minute to 640 revolutions per minute for operational adjustments of the two gearboxes 3 and 4 and the gear-driven self-powered permanent magnet generator 5. The combination of the power control system being the 2.2 kW drive motor 2 coupled to the two gearboxes 3 and 4, of which gearbox number 24 is a bespoke design, as well as the 12 kW gear-driven self-powered permanent magnet generator 5, the system can be adjusted and operated 24/7 and 365 days to produce continuous green energy power supply. Variable frequency drive inverter. The drive motor 2 of the gear-driven self-powered permanent magnet generator 5 continuous green power supply system will be powered through either 2 or 3 variable frequency drive (VFD) inverters, the number of variable frequency drive (VFD) inverters depending upon the power requirement of the system to be powered by the drive motor 2. For drive motors 2 of 100 kW or less, power will require two inverters, inverter number 110 and inverter number 219. Drive motors 2 above 100 kW will require three variable frequency drive (VFD) inverters 10, 19 and 20. For drive motors 2 at or below 100 kW, the variable frequency drive (VFD) inverter number 110 will be coupled to a 12V DC battery, which is charged continuously from a connected battery charger which receives power from the gear-driven self-powered permanent magnet generator 5. When the battery is fully charged, it will be switched off and the battery charger will send 12V DC to the variable frequency drive (VFD) inverter number 110, which will then send 220 VAC to variable frequency drive (VFD) inverter number 219, which will send 380 VAC to the drive motor 2. For drive motors 2 above 100 kW, the variable frequency drive (VFD) inverter number 110 will be coupled to a 24 or 48 VDC battery bank. Size depends on the size of drive motor 2, which is charged continuously from a connected battery charger which receives power from the gear-driven self-powered permanent magnet generator 5. When the battery bank is fully charged, it will be switched off and the battery charger will send 24 VDC or 48 VDC, as the case may be, to variable frequency drive (VFD) inverter number 110, which will then send 220 VAC to variable frequency drive (VFD) inverter number 219, which will send 380 VAC to variable frequency drive (VFD) inverter number 320, which will send 380 VAC to the drive motor 2. Figure 4 illustrates the external power and internal power supply of the variable frequency drive (VFD) inverter number 110 to power up the asynchronous drive motor 2 of the prototype of the gear-driven self-powered permanent magnet generator continuous green power supply system. The external power source 1 to supply single-phase 220 VAC to the variable frequency drive (VFD) inverter number 110 is specifically coming from the local utility provider being Subico 1. The output of the variable frequency drive (VFD) inverter number 119 is 0 to 380 VAC 0 to 60 Hz to control the 2.2 kW drive motor 2. The pilot input power supply is coming from the output load from permanent magnet generator 5 to take over the power from the external power source 121, thus the gear-driven self-powered permanent magnet generator continuous green power supply system switches to self-power. Gearbox number 1. Gearbox number 13 is customized with the design and specification made to order from the gearbox manufacturer, with input speed of 1500 revolutions per minute, input torque at 14 Nm, and output speed of 188 revolutions per minute, output torque at 112 Nm, has been selected based on the required designed combination of the high-speed input gear and low-speed output gear with the necessary starting force expressed as rated torque. Gearbox number 13 giving a higher rated output torque of 112.0 Nm, which torque must be equal to or higher than the gear-driven self-powered permanent magnet generator 5 with its rated torque of 96.9 Nm. However, to enable the 2.2 kW drive motor 2 to operate the 12 kW gear-driven self-powered permanent magnet generator 5 with its rated speed of 1200 revolutions per minute, the input speed of gearbox number 13 has to be reduced from 1500 rpm to 1200 revolutions per minute, which will come from the input speed of the drive motor 2, which is set to operate at 1200 revolutions per minute. Accordingly, the input speed will be set within the range of 1170 revolutions per minute to 1230 revolutions per minute. The required energy, torque, for each equipment is calculated according to Newton's law formula as follows: torque, Nm, equals constant power, kW, speed, rpm with an increased output torque of 140.06 Nm, which torque will more than cover the 96.9 Nm lower rated torque of the gear-driven self-powered permanent magnet generator 5 and will overcome and easily drive the force generated by the 2.2 kW drive motor 2, set from the variable frequency drive, VFD, inverter number 110 to operate within the range of 1170 revolutions per minute to 1230 revolutions per minute, with the rated input speed reduced from 1500 rpm to 1200 revolutions per minute. In the other words, the set point output speed of gearbox number 13 is only 150.4 revolutions per minute, inducing an output torque increased from 112.0 Nm to 140.06 Nm. However, gearbox number 1 output speed of 188 revolutions per minute will not match the 1200 revolutions per minute rated speed of the gear-driven self-powered permanent magnet generator 5, which also has a rated torque of 96.9 Nm. Hence, due to the 1200 revolutions per minute input speed from the drive motor 2, gearbox number 13 now has its rated input speed of 1500 revolutions per minute reduced to 1200 revolutions per minute, with input torque increased from 14.0 Nm to 17.55 Nm, and the output torque increased from 112.0 Nm to 140.06 Nm, with an output speed reduced from the rated 188 revolutions per minute to 150.4 revolutions per minute. The bespoke design of gearbox number 24 is essential to transform gearbox number 13 low output speed of 150.4 revolutions per minute to the required 1200 revolutions per minute high output speed of gearbox number 24, having a set point allowance to be adjusted to match the 1200 revolutions per minute speed of the gear-driven self-powered permanent magnet generator 5, thus completing the operation of the bespoke integrated system. Gearbox number 2. Gearbox number 24 is bespoke and has been specifically and carefully designed and invented. Shaft diameter, gear wheel diameters and widths of the gear teeth, material specification and hardness to overcome the rated torque from gear-driven self-powered permanent magnet generator 5 without affecting the speed ratio of the input speed and output speed of the gearbox number 24, to convert the required speed ratio from the low output speed of gearbox number 13 to the 1200 revolutions per minute high speed of the gear-driven self-powered permanent magnet generator 5, from the 1200 revolutions per minute set on the drive motor 2. The rated input speed of gearbox number 24 is reduced from 188 revolutions per minute to 150.4 revolutions per minute to match the reduced 150.4 revolutions per minute output speed of gearbox number 13. The rated output speed of gearbox number 24 is decreased from 1500 rpm to 1200 revolutions per minute, which lower speed is able to drive the gear-driven self-powered permanent magnet generator 5 at the required speed of 1200 revolutions per minute. gearbox number 24 does not follow the formula of Newton's law for calculating the output gear speed and torque. Despite having the reverse speed ratio from the input and output speed and torques of gearbox number 13 and gearbox number 24 from high speed at 1500 revolutions per minute to low speed at 188 revolutions per minute and low speed 188 revolutions per minute to high speed 1500 revolutions per minute respectively, the output gear diameter and gearbox number 24 is adjusted to a larger size as well as the diameters of the input and output shafts without affecting the ratios of the speed. The input gear has a 76 mm diameter, 45 mm width, and output gear has a 164 mm diameter, 38 mm width. Both gearboxes have the same gear and shaft materials, 20 CR neat to mow and 42 CR mow, and gear and shaft hardness, HRC 5862 and HRC 580. In addition, the output shaft diameter of gearbox number 2 is bespoke, at 42 mm. Being the same 42 mm shaft diameter of the gear-driven self-powered permanent magnet generator 5. Accordingly, the bespoke design of gearbox number 24 results in an output speed at 1200 revolutions per minute, which has an allowance to anticipate the friction arising from the operation of the system for matching the operating speed of the gear-driven self-powered permanent magnet generator 5 at 1200 revolutions per minute. By duplicating the set point input speed of 1200 revolutions per minute, rated at 1500 revolutions per minute, and the output speed of 150.4 revolutions per minute, rated at 188 revolutions per minute, of gearbox number 13, and then turning gearbox number 24 by 180 degrees to mirror gearbox number 13 with an input speed of 150.4 revolutions per minute and output speed of 1200 revolutions per minute. Basically the two gearboxes 3 and 4 are precisely synchronized during the starting operation without load, since the starting torque of the gearbox number 13 is 17.55 Newton-meters, rated at 14.0 Newton-meters, at the input speed of 1200 revolutions per minute, rated at 1500 revolutions per minute, and the starting torque of the gear-driven self-powered permanent magnet generator 5 is 2.4 Newton-meters at the speed of 1200 revolutions per minute, which is equal to the set point of 1200 revolutions per minute on the drive motor 2, thus ensuring the system operates smoothly. In view of the above, and in order to operate during load shedding and load sharing, the gear-driven self-powered permanent magnet generator 5 starts on the output speed of gearbox number 24 at 1200 revolutions per minute by modifying the size and strength of the material utilized for the output gear teeth, thus equaling the output torque of gearbox number 13 gear teeth, with a calculated torque at 140.06 Newton-meters. To ensure the integrity of the output gear teeth of gearbox number 24, a high-grade material, 20 CR Nitumo, with hardness, HRC 5862, is utilized and has been specifically procured to have the same hardness, HRC 5862, as the input gear teeth, thus the output force is equal to or greater than the hardness created torque in the system, at or above 140.06 Newton-meters. The materials, 20 CR Nitumo for gear and 42 CR Mo for shaft, and hardness, HRC 5862 for gear and HB 580 for shaft, have been designed and customized to ensure the desired speed and torques. The aforementioned changes will overcome the created force to drive the rated torque of 96.9 Newton-meters of the gear-driven self-powered permanent magnet generator 5. Being that the calculation is superseded in practical ways of a lower force load that the output torque creates from the speed of gearbox number 24 at 1200 revolutions per minute, plus gearbox number 24 output shaft is being also customized with the 42 mm diameter to be the same 42 mm diameter as the shaft of the gear-driven self-powered permanent magnet generator 5, then mathematically, the material reinforcement method strengthens the gear teeth so as not to sustain damage or fail when the system operates. In summary, the hardness of the materials override the guiding principles of power and energy calculated, being energy input is equal to the output or 1:1, thus the Newton's law formula of output being equal to input is superseded by Ryanyx's law of small input, drives the bigger output to match up the speed and equaling the created force from the system comprising the 2.2 kilowatts asynchronous drive motor 2, gearbox number 1-3, gearbox number 2-4 and the 12 kilowatts gear-driven self-powered permanent magnet generator 5. With the adjustment of the sizes of the input shaft and the output shaft and the output diameter and width of the gears, it is called small input will drive the bigger output, precisely designed and invented so as to not to cause damage of any gear teeth of the two gearboxes 3 and 4 when running, not only during the starting torque phase but also the rated torque load of the gear-driven self-powered permanent magnet generator 5. In all respects the formula under Newton's law is diligently followed for the drive motor 2, gearbox number 1-3 and input gear of gearbox number 2-4 and gear-driven self-powered permanent magnet generator 5. Categorically, Newton's law is not followed for the specification of the output gear of gearbox number 2-4 which is in fact and is so deliberately designed and invented. Instead Bernoulli's law is followed. Permanent magnet generator. The gear-driven self-powered permanent magnet generator 5 is a special order supplied according to the requested specifications, with a capacity of 12 kilowatts, 380 VAC, 60 Hz, 3-phase with 4 wires, 4 poles with line and neutral and rated speed of 1200 revolutions per minute, rated current of 18.2 amp, starting torque of 2.4 Newton meters, rated torque of 96.9 Newton meters. This gear-driven self-powered permanent magnet generator 5 has been selected to initially complete the design parameters of the instant invention based on the doctrine of small input drives the bigger output and to self-power to operate 24/7 365 days supplying green energy electricity with very low maintenance with no brownouts and blackouts. Figure 5 illustrates the schematic drawing with external power supply from the local utility provider 21 for the prototype of the gear-driven self-powered permanent magnet generator continuous green power supply system. When the power supply from the local utility provider 21 is not available, the external indicating light 22 will illuminate and when the external power is available it will switch off and the external power supply indicating light 23 will illuminate at which time the operator will start the drive motor 2 by pressing the start push button 24. Thereafter, the magnetic contactor KM19 will close and power up the input power supply of the variable frequency drive, VFD, number 110. The magnetic contactor KM19 will automatically de-energize when the internal power takes over from the local utility provider 21 because the normally closed contact of the magnetic contactor KM215 takes over supply of the load from the permanent magnet generator 5. Figure 6 illustrates the schematic drawing showing the permanent magnet generator 5 taking over the power supply from the external source 1 by providing power to the drive motor 2 for the prototype of the gear-driven self-powered permanent magnet generator continuous green power supply system. When the system stabilizes from the load of the permanent magnet generator 5 and the voltages, amperes, frequency are reached, the operator will press the start button 26 to energize the magnetic contactor KM215 to take over the external power and at this stage the system is powered by itself. The operator will push the start button 40 of magnetic contactor KM625 and the test load indicating light 27 for a test load ready. The test not ready indicating light 28 will switch off. The overvoltage indicating light 29 and also the overfrequency indicator 30 will shut off at which time the operator will press the start button 31 for test load number 1 to energize the magnetic contactor KM316 and simultaneously the test load indicating light 32 will illuminate and the test load red indicating light 33 will switch off. Thereafter, the operator will push the start button 34 of test load number 2 to energize the magnetic contactor KM417 and simultaneously the test load number 2 indicating light 35 will illuminate and the red light indicator 36 will switch off. Thereafter, the operator will press the load test number 3 start button 37 to energize the magnetic contactor KM518 and simultaneously the test indicating light 38 will switch and the red test load number 3 indicating light 39 will shut off. Interlocking system. The gear-driven self-powered permanent magnet generator system is protected with a range of monitoring devices such as resistance temperature device, speedometer transmitter, power transducer, current transducer, and vibration transmitter. Each monitoring device is connected to the programmable logic controller. Programmable logic controller is programmed to monitor the electrical and instrument control interlocking system and will initiate a break of the circuit once any transducer identifies an abnormality against the alarm set point and trips off the circuit. Each device has an additional trip amplifier monitoring all signals with the transmitter feed to the programmable logic controller, each having a certain alarm setting and trip point. Resistance temperature devices are monitoring the temperatures of the drive motor 2 bearings, permanent magnet generator bearings, gearbox number 1-3 oil and gearbox number 2-4 oil. Once a bearing or oil temperature reaches the temperature set point, an alarm will trigger alerting the control room operator. If the temperature goes too high, it will trip an amplifier which will give a signal to the programmable logic controller and it will automatically break the logic circuit interlocking and stop the operation of the system for immediate maintenance action. Speedometer transmitter is connected to the input shaft of the gear-driven self-powered permanent magnet generator 5 to signal the programmable logic controller to proportionally synchronize the speed and load of the drive motor 2. The signal is also connected, in series, to the input of the proportional integral controller via the trip amplifier. Once the 1200 revolutions per minute rated speed of the gear-driven self-powered permanent magnet generator 5 is reached, it will signal the power transducer to activate the switchgear to take over the power from the 12V DC battery starting power and switch to the variable frequency drive, VFD, inverter number 110 and variable frequency drive inverter number 219 to maintain 2.2 kW power to the drive motor 2 to maintain the speed and the load of the system in full operation. In other words, the 12 kW gear-driven self-powered permanent magnet generator 5 will be self-generating its own power by returning 0.4 kW to variable frequency drive, VFD, inverter number 110 which will provide 220 VEC to variable frequency drive, VFD, inverter number 219 which will provide 380 VEC to the drive motor 2. Power transducer and current transducer are connected to the power from the gear-driven self-powered permanent magnet generator 5 and the drive motor 2 to monitor the load that it will activate after the synchronization of the system. The signals of these devices are connected to the programmable logic controller to activate the switchgear and to trip to off position when the system is overloaded. Proportional integral controller receives signals from the speedometer installed on the outer surface of the permanent magnet generator 5 shaft to monitor the speed of the gear-driven self-powered permanent magnet generator 5. The output signal of the proportional integral controller will, through the variable frequency drive, VFD, inverter number 110, control the speed of the drive motor 2. Vibration transmitters monitor all bearings of the drive motor 2, gearbox number 1-3, gearbox number 2-4 and the gear-driven self-powered permanent magnet generator 5. Each bearing has an individual alarm and trip indicator in the control room and if any bearing records a high vibration level, the alarm will be indicated for immediate preventive maintenance. Step-down transformer converts high voltage, low current power into low voltage, high current power. The larger gauge wire used in the secondary winding is necessary due to the increase in current. A person skilled in the art will know that a step-down transformer works on the principle of Faraday's law of electromagnetic induction and the number of turns in the primary winding is greater than the number of turns in the secondary winding, due to which it takes high electrical voltage at its primary terminal and gives low electrical voltage at its secondary terminal. Step-down transformers are not required for a 2.2 kW per 12 kW and 45 kW per 200 kW permanent magnet generator 5 systems but are required for each 45 kW per 280 kW, 250 kW per 600 kW, 250 kW per 1000 kW, 500 kW per 1250 kW, 650 kW per 3000 kW, 1120 kW per 5000 kW, 1120 kW per 6500 kW and 1200 kW per 6500 kW permanent magnet generator 5 systems. System operation. Independent startup green power source, 5 kV will be required to start the 2.2 kW, 12 kW gear-driven self-powered permanent magnet generator continuous green power supply system. The green power source can be either wind, solar, a biodiesel generator, local utility provider connection or 12, 24, 48 VDC battery charger with battery bank, connected to a variable frequency drive, VFDDF, inverter with capability of producing at least 5 kV 3-phase 60 Hz 380 VAC power supply. The external independent startup green power source is switched on with an expected duration of only 5 to 10 minutes of stabilization of the speed, frequency, current and voltages from the gear-driven self-powered permanent magnet generator, after which time the operator will switch on the load of the gear-driven self-powered permanent magnet generator to take over the 220 VAC from the battery charger of the DC to AC variable frequency drive, VFD, inverter to power by itself, thus being self-sustaining and running 24/7 365 days. In a fully integrated power system in which multiple gear-driven self-powered permanent magnet generator continuous green power supply systems are installed, the switch to the gear-driven self-powered permanent magnet generator will be under auto mode rather than switched by the system's operator. In a multiple installation of gear-driven self-powered permanent magnet generator continuous green power supply systems, it will not be necessary to install an independent startup green power source for each system, say a 100 MW power station. Once started and synchronized, the surplus power from the designated starting system can be used to start the other systems that are interconnected and forming part of the multiple power generation installation. In fact, surplus power from any system can be used to start any other connected system. Depending upon the number of interconnected systems installed, multiple designated starting systems could be included, say every 5, 10 or 20 systems, depending on the overall system size and the number of separate gear-driven self-powered permanent magnet generator continuous green power supply systems that are installed. The drive motor capacity is 2.2 kilowatts, 380 VAC, 60 Hz and is set to operate at 1,200 revolutions per minute, rated at 1,750 revolutions per minute, which is coupled to gearbox number 1 with input speed of 1,200 revolutions per minute, rated at 1,500 revolutions per minute, and output speed at 150.4 RPM, rated at 188 revolutions per minute, with input torque at 17.55 Nm, rated at 14.0 Nm, and output torque of 140.06 Nm, rated at 112.0 Nm. The 2.2 kW drive motor has a rated speed of 1,750 revolutions per minute with a natural force of 12.0 Nm, which is increased to 14.0 Nm with a reduced speed of 1,500 revolutions per minute. The drive motor was sized and selected to drive gearbox number 1 with the input speed of 1,500 revolutions per minute with a starting torque of 14.0 Nm, and an output speed of 188 revolutions per minute with a rated output torque of 112.0 Nm. As only 1,200 revolutions per minute is required to drive the gear-driven self-powered permanent magnet generator, the speed and torque of the drive motor, gearbox number 1 and gearbox number 2 are adjusted or set to operate at 1,200 revolutions per minute, accordingly. Gearbox number 1. Output shaft, rated at 188.0 revolutions per minute, is coupled at 150.4 revolutions per minute to the input shaft, rated at 188.0 revolutions per minute, of gearbox number 2. The output speed of gearbox number 2 is 1200 revolutions per minute, rated at 1500 revolutions per minute, and is coupled to the shaft of the gear-driven self-powered permanent magnet generator with a rated speed at 1200 revolutions per minute, 12 kilowatts capacity, 380 per 220 vac output load voltage. Gearbox number 2 has an input torque of 140.06 Nm, rated at 112.0 Nm, and an output torque of 25.2 Nm, rated at 14.0 Nm. Through the larger input and output gear diameters and widths, gearbox number 2 will drive the lower force or torque of 96.9 Nm of the gear-driven self-powered permanent magnet generator. When power from either wind, solar, biodiesel generator, local utility provider or a battery charger is available, the control room operator will start up the gear-driven self-powered permanent magnet generator system. The operator will switch first into manual mode and to manually adjust the proportional integral controller at maximum speed of the drive motor, up to 1200 revolutions per minute ±- 2.5%. Once the speed of the drive motor and the two gearboxes are established and synchronized with the rated speed of the gear-driven self-powered permanent magnet generator as well as the output voltage, frequency and the load capacity, the operator will switch the variable frequency drive (VFD) inverter to auto mode. When all correct readings are established and steady, the operator will activate the circuit breaker connected from the output voltage and load from the gear-driven self-powered permanent magnet generator to deliver power back to the drive motor and at the same time shut off the standby startup power supply circuit breaker. When switched to auto mode, the gear-driven self-powered permanent magnet generator system is powered by itself, with the remaining load balance sent for use in the plant, factory or to the local electric utility and operates non-stop 24/7 365 days. The drive motor is controlled by the proportional integral controller via an input signal from the speedometer of the gear-driven self-powered permanent magnet generator, and the other input signal is connected in series to the power transducer of the drive motor. The input signal of the speedometer transmitter connected to the output shaft of the gear-driven self-powered permanent magnet generator and the output signal from the proportional integral controller are connected to the variable frequency drive (VFD) inverter to control the speed of the drive motor from 1750 revolutions per minute to 1200 revolutions per minute, which is fixed with the set point in auto mode at maximum of 1230 revolutions per minute. To avoid overspeeding gearbox number 1 as well as gearbox number 2, and also the output signal of the proportional integral controller is connected in series to the trip amplifier to arm the interlocking system, which will ensure safety of the equipment, thus avoiding overloading, overspeeding, vibration, and overheating by providing temperature monitoring. The drive motor is coupled to gearbox number 1 and gearbox number 2, with gearbox number 1 having a reduced input speed of 1200 revolutions per minute, rated at 1500 revolutions per minute, and the increased input torque to 17.55 Nm, rated at 14.0 Nm, and a rated output speed of 188 revolutions per minute, creating an output torque of 112.0 Nm according to the Newton's law formula of torque, Nm, equals constant power, kW, speed, RPM. The rated 112.0 Nm output torque of gearbox number 1 with a rated output speed of 188 revolutions per minute, which coupled to gearbox number 2 with a rated input speed of 188 revolutions per minute and rated output speed of 1500 revolutions per minute is needed to drive the 12 kilowatts gear-driven self-powered permanent magnet generator with a rated torque of 96.9 Nm, which is lower than the rated 112.0 Nm output torque of gearbox number 1. Theoretically computed, the set point of the drive motor is only 80% necessary to cover the 100% rated speeds of gearbox number 1 and gearbox number 2, respectively. To achieve and satisfy the rated speed of the gear-driven self-powered permanent magnet generator operating at 1,200 revolutions per minute with a rated torque of 96.9 Nm, gearbox number 2 is designed and customized to transform the rated input speed from 188 revolutions per minute to an output speed of 1,500 revolutions per minute with an allowance higher than the speed of the gear-driven self-powered permanent magnet generator in order to overcome the friction tendency of the overall system. At this point, theoretically, the Newton's law formula is inconsistent and out of the concept. Instead of following the Newton's law formula, the design of gearbox number 2 requires the material specification, 20 cr neat 2 Mp4 gear and 42 cr Mp4 shaft, and hardness, HRC 5862 for gear and HB 580 for shaft, of the output gear teeth and shafting, as well as customizing the output shaft to ensure that the gear components are identical in strength. Due to the hardness of output gear teeth and shaft, the bearings used in gearbox number 2 have been specified to be high resistance. These changes sustain the force created, 140.06 Nm, from the input speed of 150.4 revolutions per minute and output speed up to 1,200 revolutions per minute, which is the rated speed of the gear-driven self-powered permanent magnet generator. The question arises concerning loads placed on gearbox number 1 and gearbox number 2 with a force of 112.0 Nm, which theoretically there will be a friction impact from the drive motor, which occurs when the drive motor runs coupled with the two gearboxes without the gear-driven self-powered permanent magnet generator installed. In such circumstances, gearbox number 1 will run freely, without load, with an input speed of 1,500 revolutions per minute and output speed of 188 revolutions per minute. Accordingly, when the gear-driven self-powered permanent magnet generator is coupled with gearbox number 2, the actual load of the drive motor is 96.9 Nm, being the rated torque of the gear-driven self-powered permanent magnet generator, which is lower than the force of 140.06 Nm, and it is equivalent set point of the drive motor. The load of the drive motor still has an allowance to overcome the friction impact, while gearbox number 1 and gearbox number 2 are running at 80% of the rated speeds and rated torques, to match the rated 1,200 revolutions per minute speed of the gear-driven self-powered permanent magnet generator. During operation, the proportional integral controller and the variable frequency drive (VFD) inverter both play a key role of controlling the drive motor with two input signals from the shaft of the gear-driven self-powered permanent magnet generator, the speedometer, and from the power transducer of the load of the drive motor. The output of the proportional integral controller is connected to the variable frequency drive (VFD) inverter, with an input speed signal from the speedometer transmitter installed on the shaft of the gear-driven self-powered permanent magnet generator and the signal from the power transducer of the load of the drive motor as a cascaded control of the proportional integral controller. When the input signal, RPM and load, will be synchronized, the switchgear will be energized and the 2.2 kW power will be returned back to the 2.2 kW drive motor to be powered by itself, and the excess power will be dispatched to the local utility provider. The premise of the gear-driven self-powered permanent magnet generator is to be initially started from an external independent green power source, 5 kV amps starting the low power, 2.2 kW, drive motor, and through the RPM and torque differentials of the two inline gearboxes, drive a higher powered permanent magnet generator. 12 kW less 7% efficiency loss equals 11.16 kW net, from which 2.2 kW is returned to the drive motor for the system to be powered by itself, 0.052 kW for the cooling fan motor, and another 0.1% operates the electronic and electrical controls of the system, with the balance of 8.897 kW. 12 kW less 7% equals 11.16 kW less 0.01116 kW equals 11.149 kW less 2.2 kW equals 8.949 kW less 0.052 kW equals 8.897 kW, being sent to the plant, factory or local power utility provider, and the cycle continues indefinitely until either a breakdown occurs or scheduled maintenance of the gear-driven self-powered permanent magnet generator system or is switched off. The system will operate with a 93% performance efficiency at 1200 revolutions per minute set point from the drive motor and 74.14% of the output of the gear-driven self-powered permanent magnet generator delivered to the local utility provider under 24/7 365 days operation. Claims. The instant invention is not intended to be restricted to the details of the above described embodiments. It is understood that the embodiments described herein are merely illustrative of the instant invention. Variations in the applications and implementation of the gear-driven self-powered permanent magnet generator system may be contemplated by one of ordinary skill in the art without limiting the intended scope of the instant invention disclosed herein and as defined by the following claims. What is claimed is: 1. A gear-driven self-powered permanent magnet generator system comprising a system that defies Newton's first law of motion that states that it is not possible to get more from a system than is put into the system. In other words, for units of energy used to power into a system, the system can only return same number of units of energy. A drive motor operating at high speed and receives initial start power from a green power source such as wind, solar, biodiesel generator, local utility provider, or a battery-powered variable frequency drive, VFD, inverter powering other variable frequency drive, VFD, inverter/S, a drive motor that after receiving its initial start power from a green power source and after system synchronization will receive continuous non-stop power 24/7 365 days, from the gear-driven self-powered permanent magnet generator, a first gearbox, wherein the first gearbox input shaft is connected by shaft coupling to the drive motor output shaft that will rotate the small input gear of the first gearbox at high speed and low torque, which is connected to the large output gear of the first gearbox which runs at low speed and high torque, a second gearbox, wherein the input shaft of the second gearbox is connected by shaft coupling to the low speed output shaft of the first gearbox that will rotate the large input gear of the second gearbox at the same low speed and high torque of the large output gear of the first gearbox and rotates the small output gear of the second gearbox at a high speed and low torque. A permanent magnet generator, wherein the drive shaft is connected by coupling to the high-speed output shaft of the second gearbox and drives the permanent magnet generator at its rated speed and rated torque, which induces the permanent magnet generator to produce its rated power at its rated efficiency, and which returns power to the drive motor and power for the support control and instruments, with the balance power available to deliver for other use or to local utility producer, a plurality of variable frequency drive, VFD, inverters that are linked together to receive 12 DAC digital to analog converter, 24 DAC or 48 DAC power to the first variable frequency drive, VFD, inverter from a battery bank charged by a battery charger with the first variable frequency drive, VFD, inverter supplying 220 VAC to the second variable frequency drive, VFD, inverter which will supply 380 VAC to the third variable frequency drive, VFD, inverter which will supply 380 VAC power to the drive motor. A plurality of embodiments of the gear-driven self-powered permanent magnet generator system include a system that does not require power to be returned to the drive motor, which will receive power from wind and or solar, if available, with backup from the local utility provider. 2. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein the drive motor is an asynchronous drive motor of 2.2 kW power, but other embodiments of the gear-driven self-powered permanent magnet generator system may have drive motors with higher power capacities such as, but not limited to 45 kW, 250 kW, 500 kW, 650 kW, 1120 kW and 1200 kW. 3. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein embodiments of the instant invention may also include asynchronous drive motors driving induction generators, synchronous drive motors driving permanent magnet synchronous generators, and synchronous drive motors driving induction generators. 4. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein in addition to a green power source such as wind, solar, biodiesel generator or local utility provider, for 100 kW drive motors or below, 112V DC battery-powered variable frequency drive, VFD, inverter will power 220 VAC to a second inverter which powers 380 VAC to the drive motor, and for motors above 100 kW 24 VDC or 48 VDC powers the first variable frequency drive, VFD, inverter which powers 220 VAC to the second variable frequency drive, VFD, inverter which powers 380 VAC to a third variable frequency drive, VFD, inverter that will power 380 VAC to the drive motor. 5. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein drive motors at or below 100 kW the first variable frequency drive, VFD, inverter will be coupled to a 12V DC battery which is charged continuously from a connected battery charger which receives power from the permanent magnet generator, and when the battery is fully charged it will be switched off and the battery charger will send 12V DC to the first variable frequency drive, VFD, inverter which will then send 220 VAC to the second variable frequency drive, VFD, inverter which will send 380 VAC to the drive motor. 6. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein drive motors above 100 kW the first variable frequency drive, VFD, inverter will be coupled to a 24 or 48 VDC battery bank. Size depends on size of drive motor, which is charged continuously from a connected battery charger which receives power from permanent magnet generator, and when the battery is fully charged it will be switched off and the battery charger will send 24 VDC or 48 VDC, as the case may be, to the first variable frequency drive, VFD, inverter which will then send 220 VAC to the second variable frequency drive, VFD, inverter which will send 380 VAC to the third variable frequency drive, VFD, inverter which will send 380 VAC to the drive motor. 7. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein the 2.2 kW drive motor is asynchronous variable frequency at 3-phase 60 Hz 380 VAC with a rated speed of 1750 revolutions per minute operating at 1500 revolutions per minute but with the 80% set point at 1200 revolutions per minute and torque of 17.55 Nm plus, minus 2.5% to match the rated 1200 revolutions per minute speed of the synchronous permanent magnet generator connected by a 28 mm drive shaft to the 28 mm input shaft of the first gearbox. 8. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein the 28 mm input shaft of the first gearbox is connected to the 28 mm drive shaft of the drive motor and at 80% set point drives the input gear at 1200 revolutions per minute, rated 1500 revolutions per minute, at input torque of 17.55 Nm, rated 14.0 Nm, connected to a 30 mm output shaft driving the output gear at 150.4 revolutions per minute, rated 188 revolutions per minute, at output torque of 140.1 Nm, rated 112.0 Nm, connected by coupling to the 35 mm input shaft of the second gearbox. 9. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein the 30 mm output shaft of the first gearbox is connected by coupling to the 35 mm input shaft of the second gearbox and at 80% set point drives the input gear of the second gearbox at 150.4 revolutions per minute, rated 188 revolutions per minute, at input torque of 112.0 Nm, rated 140.1 Nm, driving a 42 mm output shaft which drives a bigger and heavier size output gear, 76 mm diameter / 45 mm width, at 1200 revolutions per minute, rated 1500 revolutions per minute, at an output torque determined by Ryanyx's law. Small input drives the bigger output, connected by coupling to the 42 mm drive shaft of the permanent magnet generator which requires a rated torque of 96.9 Nm at the rated speed of 1200 revolutions per minute. 10. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein the 42 mm drive shaft of the permanent magnet generator is connected by coupling to the 42 mm output shaft of the second gearbox, and when the rated speed of 1200 revolutions per minute is reached, the permanent magnet generator synchronized with the drive motor and returns 2.2 kW/0.052 kW to the drive motor, fan motor and 0.011 kW for system use, with surplus power available for other use or sold to the local utility provider. 11. The gear-driven self-powered permanent magnet generator system of Claim 1, wherein the system is protected by an interlocking system comprising programmable logic controller to monitor the electrical and instrument control interlocking system, resistance temperature devices that monitor the temperatures of the drive motor bearings, permanent magnet generator bearings, gearbox number 1 oil and gearbox number 2 oil, speedometer transmitter connected to the input shaft of the permanent magnet generator to signal the programmable logic controller to proportionally synchronize the speed and load of the drive motor, power transducer and current transducer to the power from the permanent magnet generator and the drive motor to monitor the load that it will activate after the synchronization of the system. Proportional integral controller receives signals from the speedometer installed on the outer surface of the permanent magnet generator shaft to monitor its speed, vibration transmitters to monitor all bearings of the drive motor, gearbox number 1, gearbox number 2 and the permanent magnet generator, and step-down transformer which converts high voltage, low current power into low voltage, high current power. 12. Gear-driven self-powered permanent magnet generator systems can be upscaled to allow for installation of drive motor per permanent magnet generator combinations of but not limited to 45 kW per 200 kW, 45 kW per 280 kW, 250 kW per 600 kW, 250 kW per 1000 kW, 500 kW per 1250 kW, 650 kW per 3000 kW, 1120 kW per 5000 kW, 1120 kW per 6500 kW and 1200 kW, 6500 kW. Different size combinations could be linked together in a single power station. 13. Multiple interconnected gear-driven self-powered permanent magnet generator systems could be installed adjacent to the substations of existing coal, bunker fuel, diesel, gas-fired power stations being directly connected to the substation. Thus the existing fossil fuel supply systems of such stations could be shut down. For example, 100 megawatts would consist of 21,200 kilowatts drive motor / 6,500 kilowatts permanent magnet generator systems installed, of which 20 systems would be operating 24/7 365 days and one X system available as standby online to cover scheduled maintenance and breakdowns. Existing power purchase agreements would still be maintained for the owner, with the added advantage that green power supply will be distributed through the existing substations without any competition of the power rate. 14. For wind turbines operating at expected efficiency between 25% to 40% and solar farms at typically 30% efficiency, the gear-driven self-powered permanent magnet generator will be able to be installed, new, or retrofitted, existing wind and solar power plant, to increase wind, solar turbine efficiency to about 100% to become base load. Equipment description: gear-driven self-powered permanent magnet generator. Continuous green power supply system comprises 1. Independent green startup power. Minimum 5 kV amps that can be either wind, solar, biodiesel generator, battery charger or connected to the local utility provider. Producing 3-phase 60 Hz 380 VAC power supply. 2. Asynchronous, variable, frequency, drive motor, 2.2 kW 3-phase 60 Hz and 380 VAC. Rated to set point. Rated power. Rated 2.2 kilowatts. Set point 2.2 kilowatts. Output speed. Rated 1750 revolutions per minute per 1500 revolutions per minute. Set point 1200 revolutions per minute ±2.5%. Output torque. Rated 12.0 Newton meters per 14.0 Newton meters. Set point 17.55 Newton meters. Output shaft diameter. Rated 28 millimeters. Set point 28 millimeters. Shaft material. Rated 42 cr Mo. Set point 42 cr Mo. Shaft hardness. Rated HB 286. Set point HB 286. Bearings. Rated NSK. Set point NSK. Seals. Rated NOK. Set point NOK. 3. Gearbox number 1, high speed to low speed. Rated to set point. Input shaft high speed. Rated 1500 revolutions per minute. Set point 1200 revolutions per minute. Output shaft low speed. Rated 188 revolutions per minute. Set point 150.4 revolutions per minute. Input torque. Rated 14.0 Newton meters. Set point 17.55 Newton meters. Output torque. Rated 112.0 Newton meters. Set point 140.1 Newton meters. Input shaft diameter. Rated 28 millimeters. Set point 28 millimeters. Output shaft diameter. Rated 30 millimeters. Set point 30 millimeters. High-speed input gear diameter and width. Rated 25 and 22 millimeters. Set point 25 millimeters and 22 millimeters. High-speed input gear diameter and width. Rated paired outer rated 2 millimeters and 15 millimeters. Set point paired outer minus 82 millimeters and 15 millimeters. Low-speed output gear diameter and width. Rated 21 millimeters and 30 millimeters. Set point 21 millimeters and 30 millimeters. Low-speed output gear diameter and width. Rated paired outer minus 107 millimeters and 30 millimeters. Set point paired outer minus 107 millimeters and 30 millimeters. Gear and shaft materials. Rated 20 cr neat to Mo and 42 cr Mo. Set point 20 cr neat to Mo and 42 cr Mo. Gear and shaft hardness. Rated HRC 5862 and HB 580. Set point HRC 5862 and HB 580. Bearings. Rated NSK. Set point NSK. Seals. Rated NOK. Set point NOK. 4. Gearbox. Number 2, low speed to high speed. Rated to set point. Input shaft low speed. Rated 188 revolutions per minute. Set point 150.4 revolutions per minute. Output shaft high speed. Rated 1500 revolutions per minute. Set point 1200 revolutions per minute. Input torque. Rated 112.0 Newton meters. Set point 140.1 Newton meters. Output torque. Rated Ryanyx law. Set point Ryanyx law. Input low speed shaft diameter. Rated 35 millimeters. Set point 35 millimeters. Output high speed shaft diameter. Rated 42 millimeters. Set point 42 millimeters. Low speed input gear diameter and width. Rated 164 millimeters and 38 millimeters. Set point 164 millimeters and 38 millimeters. High speed output gear diameter and width. Rated 76 millimeters and 45 millimeters. Set point 76 millimeters and 45 millimeters. Gear and shaft materials. Rated 20 cr neat to Mo and 42 cr Mo. Set point 20 cr neat to Mo and 42 cr Mo. Gear and shaft hardness. Rated HRC 5862 and HB 580. Set point. HRC 5862 and HB 580. Bearings, highest resistance. Rated. NSK. Set point. NSK. Seals. Rated. NOK. Set point. NOK. 5. Permanent magnet generator 12 kilowatts 3-phase, 60 Hz and 380 vac. Rated power. 12 kilowatts. Efficiency. Greater than 93%. Rated speed. 1,200 revolutions per minute. Start torque. 2.4 Newton meters. Rated torque. 96.9 Newton meters. Shaft diameter. 42 millimeters. 6. Variable drive frequency inverter. 60 Hz, 380 vac, 2.2 kilowatts. 7. Proportional integral controller. Input and output from 4 mA to 20 mA. 2.2 kilowatts to 12 kilowatts. Gear-driven self-powered. Permanent magnet generator system. Picture of actual prototype showing the drive motor coupled to gearbox number 1 coupled to gearbox number 2 coupled to the permanent magnet generator with all power supply connected to the control panel. Also shows speed and torque parameters of the connected equipment as well as frequency, voltage and power. Number 1. 5 kV amps green startup power. Wind, solar, biodiesel generator and battery bank inverter. Number 2. Asynchronous drive motor. 2.2 kilowatts, 3-phase, 380 vac and 60 Hz. Output speed, 1,200 revolutions per minute. Number 3. Gearbox number 1. High speed to low speed. Input speed, 1,200 revolutions per minute. Output speed, 150.4 revolutions per minute. Input torque, 17.55 Newton meters. Output torque, 140.06 Newton meters. Number 4. Gearbox number 2. Low speed to high speed. Input speed, 150.4 revolutions per minute. Output speed, 1,200 revolutions per minute. Input torque, 140.06 Newton meters. Output torque, Baranein's law. Number 5. Synchronous permanent generator. 12 kilowatts. 3-phase .380 vac and 60 Hz. Rated speed, 1,200 revolutions per minute. Start torque, 2.4 Newton meters. Rated torque, 96.9 Newton meters. Drive motor. Gearbox 1. Gearbox 2. Permanent magnet generator. 2.2 kilowatts drive motor plus mechanical gearboxes 1 and 2. 12 kilowatts, 380 vac, 60 Hz synchronous permanent magnet generator. .45 kilowatts drives 300 kilowatts, permanent magnet generator. 90 kilowatts drives 350 kilowatts PMG, permanent magnet generator. 110 kilowatts drives 600 kilowatts PMG, permanent magnet generator. .250 kilowatts drives 650 kilowatts PMG, permanent magnet generator. 250 kilowatts drives 1000 kilowatts PMG, permanent magnet generator. 500 kilowatts drives 1500 kilowatts PMG, permanent magnet generator. 600 kilowatts drives 2000 kilowatts PMG, permanent magnet generator. 650 kilowatts drives 3000 kilowatts PMG, permanent magnet generator. 650 kilowatts drives 3500 kilowatts PMG, permanent magnet generator. 1110 kilowatts drives 5000 kilowatts PMG, permanent magnet generator. 1250 kilowatts drives 6500 kilowatts PMG, permanent magnet generator. Permanent magnet generator. This is one line diagram for the prototype. 2.2 kilowatts drives 12 kilowatts PMG, permanent magnet generator. A schematic, control drawing, with external power supply. A schematic drawing prototype, powered by itself of the permanent magnet generator PMG. Internal control box and power supply, from external power, powered by itself, by permanent magnet generator, PMG. This is the external control box layout and outer control display panel. The drawing layout of gearboxes 1 and 2, and the specifications. Helical gearbox. Picture of internal gearbox, gear shaftings and bearings. Internal pictures of gear bearings and shaftings.